Evening, guys. I apologize. I normally have the answer to that joke covered over, but I forgot today, so no big deal. Um, Anyways, so we're going to be moving on now. I told you that we're going to be moving on to function notation. You guys can thank me for getting this posted before I go to golf. I'm now going to be a few minutes late, but that's all right. I wanted to get this up before I left. So the first thing I'd like to start with, all right, so we're going with function notation, is I want you, when you guys turn these notes in on Wednesday, you will need to have these definitions down, and I need a true definition either from a math book or from the dictionary. Remember, you're looking for the definition that actually relates to mathematics, all right? Because there are plenty of definitions for the word relation, but I'm looking for the one in terms of mathematics. So a lot of these you're probably going to have to look in a math book, which you all should actually have. So these are going to be the definitions. I've left them up here plenty long enough by now because you guys can just pause the video and write these all down. So I'm going to go ahead and I'm going to go back to the first slide here, and we're going to look at example number 1. All right. Now, the concept that's being used here is something we call substitution, which you guys should kind of know what the word substitution means. If you think of the word substitution in regards to sports, if you have a substitute, then one guy will come out and the next person will go into play, and that's going to be the substitution. All right. It's the same idea here. You start with the function f of x equals x plus 2, and I'm asking you to find f of 8. Well, if you look, the only thing that changed between this and this was that the x got replaced with an 8 right here. So to find f of 8, all I'm going to do then is also replace the x with 8 here. So this would be 8 plus 2. Now I suggest when you first do the substitution that you put the number in parentheses, because that'll keep you, if this happens to be a negative number, it might keep you from making an important mistake. So that means that f of 8 then is going to be 8 plus 2, which is 10. And this is how you evaluate a function. Now, all a function is this is saying that the f stands for function, all right? So it's the function in terms of x, okay? If it's g of x, then it's the g function, or the function g in terms of x, or in terms of whatever this variable is. This variable does not matter. It can be x, it could be s, it could be n, m, o, p, whatever. It can be any variable. It does not matter. As well can this one, all right? And so for function notation then, again, you just plug those numbers in. All right, so let's go ahead and let's look at another one. And we're going to evaluate. So you have the function f in terms of t. All right, the function itself is 2t squared plus 5, and that's why the t is here. So now I'm asking you to find f of 3. So that's going to be 2 times 3 squared plus 5. All right, this is 2 times 3 squared is 9 plus 5. 2 times 9 is 18 plus 5, which means f of 3 is 23. Okay, function notation is really not a hard concept. They're actually fairly easy. I mean, it does get a little bit tougher when I start putting in composition of functions, and you also start dealing with some other stuff, okay? One of the definitions we're going to be dealing with here is going to be the domain and the range, which is actually going to come into play in our next example. So it says, given the domain, find the range of the function. Now the domain is going to be all of the x values, okay? Your domain is always referring to your x values. Your range is always referring to your y values. F of x and y are actually somewhat interchangeable, okay? If I was going to graph this function, I would graph the function y equals 2x plus 1. But because it's in function notation, it's f of x instead of y. So they're kind of interchangeable here. So what you're going to do, or what this is essentially asking for, is I want f of 0, I want f of 3, and I want f of 5. And this is what we call set notation, where you have the little brackets here, and then you have the numbers inside. So when you find the function values, you're going to put those in set notation, and that's going to be our range. So this would be 2 times 0 plus 1. This is 0 plus 1, which means f of 0 is going to be 1. This is 2 times 3 plus 1. 2 times 3 is 6 plus 1, which means f of 3 is 7. And this is 2 times 5 plus 1, which is 10 plus 1, which means f of 5 is 11. So my range then is the set 1, 7, 11. And that would be your range. Okay? So again, function notation is fairly easy itself. We will get into some other stuff that might be a little more difficult, like inverse functions. We will also get into composition of functions, all that kind of stuff. Multiplying functions, dividing functions, all that kind of stuff. So these definitions will be very important so that you know what I'm talking about when I refer to one of them. Like if I say, give me the domain of a function, or give me the range of a given function, or what is the input or the output, or the origin, or any of that kind of stuff, this stuff is going to come into play. So make sure you get these definitions written. I hope you guys have a great night tonight. Please be on your best behavior for my sub tomorrow. And be prepared to work tomorrow in class. All right, we'll see you guys Wednesday.